Okay, so here is an example. Can you see I have a short video for you guys? Let me present this one to you guys. And please tell me, oh, we don't want this one. Please tell me if you could see it. Over
Yes.
here, let me explain me what they're doing. All of you know that what are balloons, correct? Amir,
Yes.
you know that? Thumbs up.
Yeah.
Okay. Yes, every one of us know. Okay. Now, what she's doing, that she is inflating a balloon. She is putting the gas inside, and I want you to observe what happened. Okay. There is nothing fancy. You all know how to blow a balloon, but I really want to see. I would really want you to see it. Okay. So what did she? Guys, can you all see it?
Yes,
Yes,
teacher.
yes.
Okay.
Yes.
Okay.
Yes.
Awesome. Awesome. So she took the balloon. Amir, can you see? Please say in the chat box. Okay. Can you see how it is? And then she inflated a little. Okay, and then she will put this in an airbag. She will fix it, and then she will inflate. Have you seen such an inflation, by the way?
No. No.
Okay, can you see what's happening to the balloon?
Wow. That is pure talent. It is.
It's expanding, isn't it? Here is the topic. Today our topic is this: gases, balloon inflation. Okay, one of the most interesting topics we have in the history of mankind. Okay, guys, do you believe that when this girl was putting air or inflating this balloon, okay, let me grab my pen. Okay. When she was inflating it, do you believe that, so let me draw a balloon in front of you so you could get an idea what I'm saying. So over here, this is my marvelous balloon, okay, and it have a smiley face on it. I know that you have never seen a creepy balloon like this before. Okay. Do you believe that when this girl was inflating the air inside, that the gas, okay, the gas will exert a pressure on the walls of the balloon and then it will expand? How many of you believe that? That gas
Yes, I do.
will exert a pressure on the walls of the balloon. On the walls of balloon. Please show me thumbs up if you believe so.
1 second.
1 second, teacher, my thumbs up is somewhere. Okay. Excellent job. Okay, Asim. Okay, now here is the case. Here is the big phenomenon. Remember, all the gases exert pressure. All the gases in this world exert pressure. They put a pressure on the things around them. Is it clear? This is the first rule of gases, okay? But the thing is that this pressure which gases exert on the things, maybe if they okay, remember, gases also exert a pressure on us also, because whole air is made up of gas, isn't it? But the thing is, we cannot feel it, isn't it? We don't get expanded and become a big thing, isn't it? This is because the pressure of the gas depends on two things. How many things?
Two things.
Two things. The first one is temperature. The second one is volume. Okay? Okay. Now, what is temperature? For sure you know. Isn't it, Lamin? Or you don't know?
Yeah.
Yeah, I know.
I know. What is volume?
Amount of space that
Space of a
substance.
substance.
Exactly. Perfect. Yes.
Can
Amount of space, which
occupies space.
Exactly. Amount of space.
Handling.
A substance will occupy. Okay, not which here. Okay, now here's the thing. Now the next part is more easier. Okay, first of all, we will learn that how pressure, so as I told you, gases okay, exert pressure. And this pressure depends on two things, which is temperature. We will talk about temperature first, okay?
Yeah.
Let's suppose I have a liquid. Oh no, I have a gas inside a container, okay? Let's suppose the name of the gas is oxygen. Oxygen gas. I have an oxygen gas inside the container, and here are the particles of oxygen. Okay, these are exerting a pressure on this. Of course, they are moving and they are trying to push the container, isn't it?
Yes.
Yeah.
Let's suppose after some time, what did I do? I put the gas on a stove and I provided some heat. So this means I'm rising the temperature, correct?
Yeah.
So I am increasing the temperature, increase temperature, correct? Now, what will happen when the temperature will increase? Do you believe that these gas particles will gain more energy and they will vibrate more fast?
Yes, It will teacher. gain more energy.
Exactly. Do you believe that?
Yes.
So the gas particles, so I'm writing here gas particle, this means particle, a circle, will gain energy, okay, gain energy, and they will move fast, isn't it?
Yes.
Okay,
Yes.
so I increase the temperature, gas particles move fast. When they move fast, do you believe that they will collide more? They will exert more pressure because now they can move fast, so they can, maybe they will bump into the container 2 times, 3 times, 4 times, so they will exert a pressure, isn't it?
But they can also go away, right?
No, let's suppose this container is closed,
Okay.
okay?
Yeah.
Do you believe that now they will exert more pressure?
Yep.
Amal,
Yeah.
Fatima, Mary?
Yes.
Amir, thumbs up, okay. For Mary, I'm telling one more time. If I have a gas in a container and the container is closed, remember, container is closed, and I turn on the heat, this means I'm increasing the temperature. The gas particles inside the container, they will gain more energy and they will move faster. Once they move faster, they will exert more pressure on the walls. Exert more pressure. Do you agree?
Yes.
Yes.
Teacher.
Okay, more pressure. Now, so from this, can I deduce one rule? The rule is that if temperature increase, the pressure will increase for a gas. Is this rule clear? Thumbs up?
Oh, yes.
Yes.
Amir, thumbs up. Excellent. Mary, how about
But
you?
this only happens right when the container is closed.
Yes, most of the time it happens this way. Yes. Okay. Excellent.
Yes.
So this is rule number 1. Remember the rule. There will be a lot of questions from here. Okay. If temperature increase, the pressure will increase for a gas. Now, what if I turn off the stove? Turn off. No heat is there. Cross.
They'll start cooling down and the pressure will come down.
Yeah.
Excellent. So do you believe
The
that
pressure.
these particles now they will have less energy because the temperature is cooling
Yes.
down, temperature is
Yes.
decreasing,
Yes.
Yes.
and again the pressure will decrease. Do you believe
Yes.
so? Is this thing
Yep.
clear?
Yes.
So can I make rule number 2? What's rule number 2 now? Please, you guys have to tell me. That if temperature
If the decreases,
decreases, okay, what happened? The pressure
the pressure like will also decrease.
will decrease for a gas, correct? Remember, it
Yes.
only happened for gas. I'm teaching you for gases, okay? Not yet liquid, not yet solid gases for, okay? So first of all,
Yes.
again, once more. Lamin, can you tell me gases exert pressure, yes or no?
Yes.
Okay, Amir, the pressure depends on how many things? Please write it. Mary, pressure depends on how many things? Pressure of gas depends on how many things? Yes, 2. What
2
are
things,
those?
teacher.
Excellent. What are those?
Temperature, and the second one was volume.
Volume. Can you tell me what happens when temperature increases, Mary? Mary?
Yes, teacher, it moved faster. They gain
Exactly.
energy.
And they will exert more pressure. Pressure will increase, correct? Excellent.
Yes.
Okay. Okay, Fatima, when temperature decrease, what happened?
particles cool down and there's less pressure created.
Less pressure to get it. So can I say that particles will release energy, release out energy when the temperature is decreased? Aman, is it clear? Is the statement clear? Yes or no?
Yes.
Excellent job. So the first one is that done. Now let's come to pressure. Now let's come to volume. Now before I come to volume, let me show you here. Can you see this picture in your book?
Yeah.
Yes. Can you see when you heat a gas over here, the vibration, first of all, was less. But once you heat it, can you see these things here?
Where did
One.
Just wait.
Yes.
Just wait. Here. Can you see these are the vibrations? They increase.
Yes.
Okay, so they're exerting more pressure. Over here, they will calm down. I increase the heat and they did that. Okay?
Yes.
Now, as you are smart
Yes.
enough, so you just told me that, Miss Binte, you just told us about temperature. How about volume? Who will tell us? Gases exert pressure. Pressure depends on temperature and volume. So we
Volume.
talk about temperature. Now let's talk about
Volume.
volume. So as you told me that volume means amount of the space. Now please here, see. Again, I have a gas, and this time I have a nitrogen gas maybe.
Mm-hmm.
Okay, inside a container. And here, nitrogen gas took this space. Okay?
Yeah.
Yes.
Okay, and let's suppose what happened that they were occupy this volume. Okay, so they were
Yes.
occupying the full container here like this. Just imagine what did I do? I become really mean and I pushed down these particles with a big, small, not small, a big machine, you could say. Okay, I was pushing down the particles. These things happen in laboratories or the big firms or industries. Okay.
Yes.
Now, if I push them down, do you believe that the situation of particles will become something like this? They will be squeezed down.
Yes.
Yeah.
Okay, so first of all, the container was like this. So do you think that their volume decreased?
Yep.
Yeah.
Okay, now please.
Yes.
So I push them up until here and over here. Army, do you believe that volume decreased here? Aman, Pat, Mary? The amount they took,
Yes.
first they were taking whole container. Now they're just taking this much amount. Do you think
Yeah.
that volume decreased? Thumbs up.
Yes.
Yes.
teacher.
Excellent job. Over here, they were, let's suppose if they were exerting just this much pressure, only one arrow is showing small pressure. Do you believe that now they will push the wall of container more?
Yeah.
Yeah.
Yeah. Do you believe so? So can I say that if volume over here, volume decrease. So can I say that if rule number 3, if volume decrease,
Pressure
what?
increase.
Excellent
Yeah,
job.
pressure increase.
Pressure increase.
Increase.
Is it clear?
Yes.
I could not see thumbs up with happiness. If this is clear.
Yeah. I mean,
Excellent, Mary. Amir. Okay. Now, here's the other rule. What will happen, Amir, Mary, Lamin, if I release this thing, if I just take it away?
The volume will increase.
Volume will increase. Do you think the pressure will remain same?
No. The
No,
pressure
so-
will also.
Exactly. So this was rule number 3. Rule number 4. If volume increase, what will happen to pressure?
decrease.
Excellent job. Excellent job. Pressure decrease. Now let's make a summary so all of you could remember. Okay.
Yes.
Here is the case again. Ayan, gases, what do? They exert
What?
pressure, correct?
Yes.
Excellent job. This pressure, Aman, depends on how many things?
What, teacher? It depend on volume and temperature. Yeah.
Temperature. Excellent job. Temperature and volume, correct? For
Yes.
temperature, we have 2 rules. What are the rules? First rule, what is the rule, Lame? If temperature,
Okay.
yeah,
If temperature increase, pressure. If temperature increase, the pressure will also increase.
Excellent. So if temperature increase, the arrow is showing increase, the pressure, sorry, I write volume. The pressure will increase too. Is it clear? Fatima, what's the second
Yeah.
one?
If the temperature decrease, the pressure will also decrease.
Excellent. If temperature decrease, downwards arrow should decrease, the pressure will decrease. You guys don't dare to write things like this. I am only allowed to write it like that just to make a summary for you, okay? Okay, for the volume part, Amir, can you tell me the first one? And Mary also? Mary, please tell me the first one. For volume, what will happen? If the volume
decrease, pressure increase.
excellent, pressure gonna increase. Good job. Okay, Amir, what's the second one?
Volume increases, pressure decreases.
If volume increases, pressure decrease or increase?
Pressure decrease.
Excellent job. Any questions up till here? No. Thumbs up for everyone? Sure? Okay, now here you go. Can you see over here that, have you seen a pressure cooker in your life?
Yes, my mom used it.
Yes.
How easy, teacher. We saw it every day in our kitchen, isn't it? Do you know what's the reason? If in IGCSE they ask you that what's the reason that food is cooked there?
It will go faster, right?
Yes, it
Because
does
it's not
faster.
letting the heat out and the particles, right?
Okay, yes. Do you believe that why the food is cooked inside? This is because of that the gas exerts a pressure. Exactly.
Yeah.
Temperature increases, container is closed, air is inside, it will move faster. Once it moves faster, it will create more heat and food get cooked.
Yes.
Okay, so the reason is here, the first one which I told you, okay?
Mhm.
Okay,
Yes.
and over here, when you squeeze a gas into a smaller space, okay? Again, can you see the difference?
Yes.
Excellent job. Excellent job. Here is the last topic and then you can go, but I'm sending a link again because it's gonna expire, okay?
Mhm.
Okay, see you. Okay, so diffusion depend on two things, okay? Diffusion of gas depend on two things. First of all, it depends on mass of the gas. Mass of gas. And secondly, it depends on temperature.
Mhm.
One of the important topics, so pay attention. Do you believe that, okay, do you believe that all gases weigh the same? They have same masses?
No.
No.
Okay.
No, remember this, yes. Some
Fire
gases,
gas is more faster than water, ice gas.
exactly. But I'm talking about their mass, or in normal, in simple English, most of the time we call it weight, okay? Not all the gases have same mass. Some gases are light and some are heavy. Remember,
Heavy, yes.
Remember, if a gas is light mass, it have lower mass, it will diffuse faster because it will move faster from high to low concentration. Do you believe so?
Yes.
Excellent job. If a gas is heavy, it have more mass. Okay, more mass, actually. This is the correct word, not heavy. I'm using it to make it easy for you. It will diffuse what? Slower.
Floor.
Yeah.
Okay? Okay?
Yep.
Okay. Now
Yeah.
here is one of the best examples they have given you in your books. Oh, please go. Okay, this one. Here, can you see the mass of the particles? Okay? Here, who will do it for me? Lamin, please go ahead and read. The particles in hydrogen chloride gas from here.
Wait, then from where?
The particles in hydrogen chloride gas.
Oh,
The mass of particles,
the
yes.
the particles in hydrogen chloride gas are twice as heavy as those in ammonia gas.
Okay, now
So
stop
which
here.
gas?
Stop.
Okay.
So there are two gases, hydrogen chloride gas and ammonia gas. Is it clear to all of you? Yes.
Yes.
And
Yeah.
he's saying that hydrogen chloride is twice heavy. And simply, hydrogen chloride is more
Heavier.
exactly than ammonia gas, okay? Which gas do you think It will move faster.
The ammonia.
The ammonia gas.
Yeah,
Oh.
the ammonia.
Ammonia. Mary, is it clear? Amir?
Yes, teacher.
Okay, now see here. So what did they do? As you know, they could never see us happy. So they performed an experiment of this. Okay, how did they perform? They took
Yes.
a tube, okay, this way. Oh, they took a tube like this. Oh, let me draw it here, and then this will be clear for you. Okay, how many pages I have to put in? Okay. So what did they do? They took a tube like this, okay, and that tube is open from two sides, like this and like this. And then
Okay.
here in one container, there was hydrogen chloride gas, HCl, and in one container, it was ammonia, NH3, yes, 3, if I'm not wrong, but let me write ammonia. Okay, it was ammonia. Okay, now then what did they do? They took a cotton ball. All of you know what is cotton?
Yeah.
Yes.
Thank
Yes.
God. Okay, and then they dip this cotton into this hydrogen chloride and this to ammonia. Okay, they took
Okay.
hydrogen chloride and then they put it here. On this container, they put ammonia and then they put on this container. Okay, what did you understand?
Like, I don't know how to explain.
Oh, come on. Okay, let me help you. Let me help you. Okay, let's suppose over here we take a tube, correct? And what did we do next, Aman?
Like, we put the gas.
Exactly. We put which gas on one side? Hydrogen chloride. Which gas we put on the other side? Mary.
Yes, teacher.
Yes, which gas we put on the other side?
It was teacher enemy like this something.
Yes,
I don't know how to pronounce.
ammonia. Okay. Okay.
Ammonia.
Amir, when hydrogen chloride and ammonia. So hydrogen chloride, and ammonia, when they come together, what happens?
Cotton.
Exactly. They will make
Like
a cloud. And what's the color of that cloud?
White.
White color. Okay. Is it clear, Aman and Ayan? Thumbs up. Okay. Now, what happened next? And now tell me this question. Answer this question. Aman, okay, let me give you. Hydrogen chloride is a heavy gas, correct? And ammonia is a light gas, okay? Now, Aman, please tell me which gas will diffuse faster? Which will go from higher to lower concentration faster?
The ammonia.
Ammonia. So over here, am I drawing correct that ammonia will go faster? The blue arrows?
I know this one.
Okay. And the red one will go slower, correct? Because they're heavy. So where do you think the white cloud will form? Near ammonia gas or near hydrogen chloride?
Exactly, hydrogen chloride.
Did you got it?
Yes, teacher. I got it.
Excellent. Now is it clear? Will you make any mistakes? No?
No, teacher.
Thumbs up for everyone. May I see thumbs up? Teacher, I understand a little bit. Amir, why a little bit? Yeah, that. Is it clear now, Amir? Please tell me in the chat box. Okay, excellent. That's why I explained again, because I don't know, I get a feeling when students don't understand. Does this happen to you? Like sometimes in your heart you're saying, I didn't understand. I hope the teacher will say it again. Does it happen to all students? Yes, no?
Yes.
Yes.
Okay, yeah. So are you happy that I said it again?
Yeah.
Okay, so
Yes.
here's the case. So in diffusion, remember, the takeaway, the biggest concept is this: heavy gases diffuse slower, light gases diffuse faster, and the experiment which they performed was this experiment. Remember, whenever you see this tube in IGCSE, because sometimes they put this tube and ask you questions about it, okay? Okay, Lamin and Fatima now come in the box. Lamin, can you tell me
Okay.
diffusion of gases depend on how many things?
Diffusion of
Gas depend on how?
volume and temperature, right?
Oh, come on. Diffusion. Fatima.
Teacher, the mass.
Mm-hmm. Mass of particles and temperature.
Mass of the particles and the temperature, yes.
So we are done with the mass of particles. Now, please tell me if
Yep.
I'm talking about diffusion of gases. If I increase the temperature, the diffusion will happen faster, or if I decrease the temperature, diffusion will happen faster.
If you increase.
Increase.
Okay.
Increase.
Increase. Mary, I just told you that when I increase the temperature of gas, do you think that the gas particles will move faster?
Yes,
Okay. If they gain more energy, do you
teacher.
think
It
they
will
will
move
go
faster. And they
exactly
gain
more energy? So do you think they will diffuse faster? They will go fast from higher concentration to lower concentration?
yes, teacher.
Excellent job. Now here is a short summary about diffusion so that you guys don't get confused. First of all, we talk about diffusion, okay? And we said diffusion means higher concentration to lower concentration, okay? Now, depends on two things, okay? Their rate, the way they're gonna fire, how fast or how slow they're gonna go. First one was mass of the particles, how heavy or slow. Second one was temperature, okay? Mass of the particles, they have two categories. Again, if I have a heavy gas, it will diffuse slower.
Slower.
Excellent, slow.
If you have a lighter gas, it will diffuse faster.
Excellent. A light gas, diffuse
Faster.
faster. Lamin, are you watching TikTok?
Yes. No. My bad. No. I'm here.
Now I
I
see
thought you was
Raman
gonna
needs
ask me.
us.
No, it's not here. I'm just
Okay.
taking notes.
Okay. Temperature, okay? Now temperature. If temperature increase, do you think diffusion will increase? Amir?
No. Oh, sorry.
Yes,
Yes.
diffusion increase. Good job. Yes, diffusion increase. Why you said no, Aman and Ayan?
My bad, teacher.
No, no. Is the concept clear? I want you to clear your concept here. Remember, Aman and
I
Ayan,
just mystically said no.
I just told you that if you increase the temperature, the gases, for sure, they will gain energy. And do you think once they gain energy, they can move faster, isn't it? Okay. Now temperature, if I increase it, so my diffusion will
Increase.
excellent job. Diffusion
Yes.
also increase. I increase. Okay, for temperature, if I decrease it, what will happen?
Like the
Diffusion will also
be
decrease.
Excellent
will be
job.
slower.
Yes, good job. Yes, decrease. Diffusion will be slower. Okay, decrease or slow. Okay. So these are the things. Will you ever forget?
No. I took notes.
No.
Okay, here's the case, guys. So this is what we learned. Okay, the temperature. And can you see? Ta-da! Chapter finished.
Huh?
Oh, yes.
And
Chapter
1
one.
month we finish one chapter.
Exactly. Can we just appreciate, guys? So happy,
Yes.
isn't it? Exactly.